everyone. So, yeah, this is Tutor Tuesday with me, Dan from Dan's Test Prep. On Tutor Tuesday, we basically go over some SAT reading, writing, math questions, sometimes math questions from other tests, ACT, AMC. But yeah, the main thing we're gonna probably focus on is digital SAT today. So, if you guys have any SAT questions to submit, you can send them in the chat. I'll be looking through the chat. Otherwise, I had like a interesting little idea that we could do today. I have this collection of random questions which we can pull, and you guys can let me know whether you want to do like a reading, writing, or a math question, and we can just do the first one that pops up. I'll start us off. I'll show you guys what I mean. So if I hit new question here, I get reading question. It's totally randomized, so I can get like reading, math, whatever. And if it looks too easy or too hard, you guys can let me know. We can look for different questions. But I think starting off with math might be like our best bet here. So that's usually a nice way to start out. So let's go ahead and do our first math question. And by the way, let me paste in the link if you guys want to pull up any random questions from here, you can, and you could send them in a chat and I'll cover them. This one's talking about the population density of Iceland in people per square kilometer of land area increased from 2.5 in 1990 to 3.3 in 2014. During this time period, the land area of Iceland was 100,250 square kilometers. By how many people did Iceland's population increase? Okay, well, if it's 2.5 people per square kilometer, that's 2.5 times 100,250. That's the number of people in 1990. And then the number of people in 2014 is represented by this number. So really we just have to multiply this out, which that's gonna be, so 3.3 times 100,000. You could even maybe estimate this. I mean, it is the digital SAT, so you do get a Desmos calculator, but this is rounds off to around 100,000. So really what we're doing is kind of equivalent to 330,000 minus 250,000, right? And 330 minus 250 is going to give us something like 80,000. And just to make sure, we can check on our calculator, but I'm pretty sure the answer should be D then. That's the closest one that we get to 80,000. Let me pull up another random question. We'll keep going with that. Let's make sure. Oh, the answer is A. Let's go back to this. By how many people did Iceland's population increase from 1990 to 2014? Well, let's see. 2.5 people per square kilometer of land area. Well, 2.5 times, yeah. I mean, the math looks right. 3.3 in 2014. So I don't see any mistakes there. I'll check that question on the back end later, though. Let's keep going. Okay, this one's a little bit too easy, so we can skip this one. Let's do a reading question. That'll be nice. All right, let me also pull this up. Okay, so this one is kind of like they give you some notes to look through, and you have to form some kind of conclusion or illustrate some kind of detail specifically. So for this one, we want to emphasize how hot the sun is relative to nearby stars. How hot the sun is relative to nearby stars. Which choice most effectively uses relevant information from the notes to accomplish this goal? Let's see. The notes are kind of saying that this astronomer is studying its differences in surface temperature. They are mapping all stars near the sun. The surface temperature of the sun is this, which makes it this kind of star. And then most of the stars were actually classified differently with cooler surface temperatures. So we can kind of look for a detail that emphasizes that, right? So at around 9800 Fahrenheit, classifies as a G star. The sun is hotter than most, but not all of the stars within 10 parsecs of it. Yeah, I mean, that could work, right? Astronomer determined that the sun is a G star and several other stars are A or F stars. That doesn't really tell us how hot it is relative to those stars. 357, okay. C could work, right? It talks about how there's a lot of stars that have this kind of surface temperature, but it doesn't really tell us what's the sun's temperature, so it doesn't really form a good comparison relative to those others. And then D doesn't really emphasize how hot it is, so A is really the best choice that emphasizes how hot this star is. So we should pick A, yes. I think we did this one in previous. Let's do this one. A nice little math question. So this one's talking about a linear function. It shows 3 values of x and their corresponding values of f of x. The function is determined by f of x equals ax plus b. Okay, so it's just a linear function, and we want to find the value of a minus b. I mean, that should be pretty simple, right? Because if you look at the table here, we go up 64 every time we go over 1 unit in the x. So the slope is 64. And the y-intercept is when x is equal to 0. That's equal to 0 as well. So really the function is defined by f of x equals 64x plus 0. So there you have your a value, and there you have your b value. So if we want to find a minus b, oh, sorry. The y-intercept is not 0, in fact. That's my mistake. But the y-intercept when x is equal to 0, if we track back using the same slope, you see we go from x equals 2 back to x equals 1, and we drop 64 units in the y. So if we wanted to go back to x equals 0, we would just go minus 64 again to minus 128. So the y-intercept is negative 128 when x equals 0. That kind of forms this equation, 64x minus 128. There's your a value and your b value. So 64 minus negative 128, we have to be careful there, is going to be 192, which is D. All right. Yeah. I was able to check on this one, and the correct answer is definitely D. So I don't know what was up with my display on the website. This one should be D as well. Yes. Okay. I guess we'll alternate between like reading, writing, and math. So here's another reading, writing question. It's kind of a long question. It's asking us which finding about the streams in the study, if true, would most directly support Liddy and Schleniger's conclusion. Okay. Well, let's see. I want to see what their conclusion actually was. So we're talking about studies of sediment in streams. There's an inverse correlation between sediment grain size and downstream distance. Sediment grain size and downstream distance from the primary sediment source. Stream length has a sorting effect on sediment. In a study of sediment sampled at more than a dozen sites, however, so contrast, geologists Camille Liddy and Fritz Schleniger found that cross-site variations in grain size were not associated with differences in downstream distance, though they did not conclude that downstream distance is irrelevant to grain size. Rather, they concluded that sediment influx in these streams may have been sufficiently spatially diffuse to prevent the typical sorting effect from being observed. That's a tough question, but right, we're just trying to focus on their conclusion, which is that here, let me highlight it in a different color, like orange. Cross-site variations in grain size were not associated with differences in downstream distance, though they did not conclude that downstream distance is irrelevant to grain size. Rather, they concluded that sediment influx in these streams may have been sufficiently spatially diffuse to prevent the typical sorting effect from being observed. So if we're looking at that problem, if we're looking at that problem, that's going to be, I would just going to go through question by question, answer by answer, and see what we can conclude, or see if any of these findings could potentially support the conclusion. The streams regularly experience portions of their banks collapsing into the water at multiple points upstream of the sampling sites. That might kind of support what we're trying to find here. What else? Streams contain several types of sediment that are typically not found in streams where the sorting effect has been demonstrated. I'm not sure about that one. That doesn't really talk about how they are spatially separated. The streams mostly originate from the same source, but the lengths vary considerably. We're not really talking about length here. Their conclusion was more about the influx of sediment into the stream. The streams are fed by multiple tributaries that carry significant volumes of sediment and that enter the streams downstream of the... Well, if it's downstream of the sampling site, that wouldn't really make sense, because now we're past the sampling site where they took the samples. So we want to be upstream of the sampling sites. If they experience portions of the banks collapsing at multiple points upstream, then that means sediment influx may have been sufficiently spatially diffuse. It might have been spaced apart enough, and that's really what we're trying to support here. I guess let's move on to another question. Some of these are not giving me the correct answer as I have it in. So let me mark these to fix later on. Okay. Oh, I think we did this one. Let's just make sure that it's working properly. So it should be, yep. This one's also a little bit too easy. Oh, there's the same question. Nice. Okay, now it's showing D. I'll kind of need to look into why that didn't show D the first time. But let's find another random question then. So we just did reading. Let's try to find a math question. Okay. This one is interesting. It's asking which of the following systems of equations has the same solution as the systems of equations graphed above. I'm going to give you guys a second to try to figure this one out. Maybe you can give me any ideas you have in the chat. I don't know. I don't see any messages yet. But what we can do for this one is if we want something that has the same solution, we have to first figure out what the solution is, and that's where these two equations intersect. That's specifically at the point, well, what it looks like to me is around 3/2 on the x and 0 on the y. Actually, I kind of see that in the answer choices, right? Like for A, y equals 0, x equals 3/2. That should just be our answer right away, because if you graphed x equals 3/2, it'd be a line that goes like this. Y equals 0 would go like that. So it should be answer choice A. Nice. Yeah, not really much work to do there. I'll save this one over here because I kind of like this one. Let's find a reading question first. All right. This one's interesting. This is a reading question that deals with the conventions of standard English. Conventions of standard English, right? SAT loves to ask these types of questions. And we're going to have to, it's the same word, but we're going to have to figure out the punctuation that goes behind it. So really, let's take a look at this sentence. Known for her massive photorealistic paintings of African American figures floating or swimming in pools, Kalita Garcia blank was the logical choice to design the book cover for Ta-Nehisi Coate's The Water Dancer, a novel about an African American man who can travel great distances through water. Okay. I just on first glance, I don't think it should have any punctuation, so I'll pick something like answer choice D. A reason for that is that we already put a comma here to separate this dependent clause from the rest of the sentence, the independent clause. We just introduced our subject, and we want to continue explaining something about that subject. So we really don't want to put any punctuation immediately after introducing the subject. We just want to go straight into explaining what that subject did. It's usually not a very good idea to separate the subject out from your verb in that kind of way. All right, next one. I think you guys can do this very quickly. This one should just be -7. Reason for this, anytime you see a quadratic, you guys should note this, especially if it's in, so this one's in vertex form. That makes it very easy for us to find the minimum, because you can see that it's a positive leading coefficient of 1. Then it's actually going to be looking like this. In the vertex form, we can clearly see that the vertex here is at -7, 4. And it's asking for what value of x does it reach the minimum. Well, the minimum for a parabola is a vertex. So that's just going to be at the x value, -7. Let me write down the equation. X minus -7. Or let me write down the standard form of the vertex form of equation. A times x minus h squared plus k. Yeah, I'm reading chat. You can ping me. I see we have a trig question in chat. Maybe we can go over it next. Actually, that's perfect because I have my unit circle right here. I don't think the SAT would ever ask you anything like this, but there is some trig concepts that do come up. So, cotangent of -13 pi over 6. It's interesting. Well, cotangent is what? Cotangent is the reciprocal of tangent, right? So like, yeah, we can do a trig SAT after this. So cotangent of x is equal to 1 divided by tangent of x, from my understanding. I believe that's correct. So using this, we can kind of I guess use this to our advantage. So if we look at where 13 pi over 6 is on our unit circle, 13 pi over 6, I know 12 pi over 6 is 2 pi, right? So let's kind of split this up. This is negative of 12 pi over 6 minus 1 pi over 6. This kind of just get canceled out into negative 2 pi. So, you know, really that's the same thing, or it's coterminal with 0 in this case. So the angle that we're really looking at is negative pi over 6, which is going to be right here. Now, tangent is also equal to sine over cosine. That means that cotangent would be equal to cosine over sine. Let's consider that. The cosine of this negative pi over 6, or the same thing as 11 pi over 6, is going to be the x-coordinate of square root of 3 over 2. And the sine is going to be negative 1/2. So when we divide this out, maybe I should move this like back into here, and also like put the unit circle somewhere. But yeah, when you divide out the square root of 3 over 2 divided by negative 1/2, that's going to be negative square root of 3. Negative square root of 3. So that makes the value of this expression equal to negative square root of 3. Yeah, if you guys have a question, you could send it in. I'm going to try to find some trig questions from the SAT. Those tend to be pretty difficult. You guys want easy, medium, or hard? Medium. Okay. I have some medium questions for you. This right here might be something that you would see on the SAT. That's characterized as a medium difficulty question. Let's just take a look and read this for a second. triangle FGH is similar to JKL. F corresponds to J. Angles G and K are right angles. Okay, so let's say, like, here's my drawing. Dang, I didn't even solve it out yet. But I will let you know if it's C soon. Let's call this FGH. Remember that G and K are right angles. And this one could be J, K, L. Right, so our similar corresponding triangles. It says sine of F is in a ratio of 308 to 317. Well, sine takes the opposite side, the ratio of the opposite side to the hypotenuse. So if we want to find sine of J, well, this is a similar triangle, right? So this angle actually corresponds to this one. It's the same thing. Same. It may not be the same side length, but it's the same ratio, which makes sine of J equal to, I guess, the same thing, 308 over 317. That's answer choice B. Hard one. Yeah, let's do a hard one. Let me find. Nah, some of these labeled as hard are not actually that hard. Some of the ones in medium were way harder. Oh, I remember doing this one. This one was annoying. See what we got here. Okay. Make that a little bit smaller. It says in this figure, tangent of B is 3 over 4. BC is 15 and DA is 4. What is the length of DE? It's a DA from here to here is 4. Tangent of B is, wait, let me label BC as well. So B to C is 15. We want to find out DE. I don't know, what do you guys think? What I think is maybe we could find the side length of this entire thing. Tangent of B, which is equal to the opposite over adjacent, right? Let's say tangent is opposite over adjacent. So let me mark this and this as 3 and 4. And box means it's a side length ratio. It's not the actual side length. That's always the confusing part. Right, tangent of B does not mean that these sides are 3 and 4. It's the side length ratio. And since this is a right triangle, that would mean that this hypotenuse would be 5, right? This is a 3, 4, 5 right triangle. You could also have calculated that with the Pythagorean theorem. So if this side length is 5 and then this side length is 4, we can set up a little ratio to find the ratio of BC corresponding to BA. Ratio of BC to BA is going to be the same thing as the ratio of BE to BD. And we know that that's equal to 5 over 4. We also know that BC is equal to 15, so we can say 15 over BA is equal to 5 over 4. And then if you kind of just cross multiply here, we get that BA is equal to 15 times 4 over 5. That's 60 over 5. That's equal to 12. So BA, the whole thing, is equal to 12. If DA is 4, that makes BD equal to 8. Now I'm looking at that, and I'm not really sure why we did that if we're looking for DE. Oh, but that does help us get closer to DE. Right, because now you have the ratio, right? This is 3 corresponding to 4. If this is 8, then DE has to be 6, which I see someone's got in a chat already. DE is equal to 6. If you wanted to properly set up that ratio, you could set up something like the ratio of BD to DE is equal to 4 over 3. Then you can substitute your values in there. You know that BD is 8 over DE is equal to 4, 3. Cross multiply to get DE is equal to 20, or say 8 times 3 over 4. That's 24 over 4, which is 6. 6. Very nice. That would be classified as a hard question. Any other topics you guys want to go over? Let me know. Advanced math, geometry. Yeah, that log question is not really like the scope of the SAT. I might come back to it. Let me do some geometry problems first. Those will be definitely more fun. I have some problems on lines, angles, and triangles. Definitely, this one is a fun one. This one is a really fun one. Let you guys take a look at it for a second. Anybody get a solution yet? It's not only SAT math prep, but it's mainly SAT math prep. I do ACT as well, sometimes AMC. I think for this one, or for like these geometry problems, I just like to write stuff down. I just like to label everything. So if EBC is 45 degrees, angle ACD is 104 degrees, and AC equals CD, those are congruent sides, what is the value of X? Okay, well, knowing this and this, or knowing that those sides correspond to each other, these two angles are also the same, which we can call them like angle A is equal to angle D, and angle A plus angle D should be equal to 180 minus 104, because the sum of the three angles in a triangle is 180. So subtracting 104 gives us the remaining amount of angles. So that's going to be what, like 76? 76 degrees split between the two means that angle A is half of that. and angle D is the other half. Yeah, X should be 83. You got that quick. I'm still writing out 38 degrees right here and 38 degrees right here. Next one, I know that there's supplementary angles right here, making this also 76 degrees, right? Because two angles on a line should add up to 180 degrees. Then we can use the triangle rule once again to get 180. Maybe I should do a different color. Like 180 minus 45 minus 76 will give us this green angle right here. So that's what 135 minus 75 is gonna give us like 60. So what does that become? 59. I hope I calculated that correctly. That's also a vertical angle. 59. So this is also 59. And then finally, we just have to do, to get x, we just have to do that again. 180 minus 59 minus 38. So I'll actually pull up my no, let me do this. So 180 minus 59 is like 180 minus 60, 120, but plus 1. So 121 minus 38 is like minus 40. 81 plus 2 is 83. Yeah, so it should be 83 degrees for x. Okay. I see we got AMC problem in the chat. We could try that out. Looks it's pretty tough. Let ABCD be a rectangle with AB equals 30, BC is 28. So let's see how we could draw that. So A, B, that's 30. This one is slightly shorter at 28. And from here to here, D is 28. That's 30. Point P and Q lie on BC and CD respectively. P corresponds to BC. So that all sides of ABP, triangle PCQ, and QDA have integer lengths. What is the perimeter of APQ? Oh. Perimeter of APQ. So P lies on BC somewhere. I don't know if you should skip those problems. Well, you should do whatever you're most comfortable with first. Let's say P is like, I don't know, here. Q in a different color is here, but they could really be anywhere, I guess. And the triangles ABP, okay, let me do that in green. ABP is this triangle. PCQ, we'll do that in like this blue right here. PCQ and QDA, Q to D to A, all have integer lengths. Integer lengths, right? I don't know, guys. One thing that we could do let's set some variables here. I see that some of these are right triangles. Actually, a lot of these, like this is a right triangle, this is a right triangle, this is a right triangle. So perimeter of APQ, all of those should probably be Pythagorean triples, Pythagorean triangles. So if we focus on, let's say, ABP, this right triangle right here, the green one, let me draw it out a little bit. We could have a 3, 4, 5 triangle. If you don't know your Pythagorean triples, there's also 5, 12, 13, and 8, 15, 17. I honestly don't know any of them past that, but we could try some of them and see if we can get one of the sides to be a multiple of 30, or to multiply to 30. Okay. So one thing we could try is like the 3, 4, 5 triangle. Yeah, that would be 5 as a hypotenuse. Then the 3 would probably factor into the 30. So like this one would be 30, 40, and 50 if we scaled everything up by 10. But that's larger than the 28 that we were given for BC. So we could rule that out. We could try 5, 12, 13. So I think that if we wanted that to be an integer, the 5 would factor in the 30. So we'd multiply everything here by 6. Then it would be 30, 72, and 78. But that's also too big, right? And then last one is 8, 15, 17. We'd probably take the 15 to factor into 30. So multiply everything here by 2. That would give us 30. And then 16 and 34. So that actually fits, right? From B to P, we know that this side length is 16. Let me do a different color, like saying that we filled it in. 16 here, and then this hypotenuse is 34, and then this side length is 30. That also makes this side 12 right here. That also fits into another Pythagorean triple, I think. But let's focus on another triangle here. So we can try with like this triangle here and see if we can get again, like starting with a 3, 4, 5 triangle. Let me draw it out here. 3, 4, 5. We know that one of the side lengths is 28, so I'd put probably the 4 here, which would multiply into 28. 3 here, which would go to 21, since we're scaling the 3, 4, 5 triangle by 7. And then the last one would be 5 goes into 35. I mean, this looks like it works because a 21 is less than 30. So, yeah, the side length here would be 21. Side length here, we know it is 28. It's the full 28. And then the side length of the hypotenuse is 35. And then we have this last triangle right here, which we can easily find the side length of, like, for example, CQ, because it's just 30 minus the 21, making this 9. And then we can again use Pythagorean theorem to get this right here. It would be something like square root of 9 squared plus 12 squared, which is 81 plus 144, or that's the square root of 225, which is 15. You could also recognize that this is another 3, 4, 5 triangle. So let me draw it out. This is a 3, 4, 5 triangle, except the actual values correspond. This one corresponds to 12, so we multiply everything by 3. 3 goes to 9, 5 goes to 15. So this side length is 15. I think we were asked about the perimeter of triangle APQ. So the perimeter is going to be the sum of those side lengths that make up APQ, which looks like 34 plus 15 plus 35. 15 plus 35 is 50, 30 plus 34 is 84. So I believe our answer is A. I missed the chat. This one should be 15. That's what I had meant to write down. 15, not 25. Oh, that was a tough one. This would be a harder geometry question. Actually, you wouldn't really see this on the SAT. You would see this on the AMC, which is more focused on like harder math questions. I don't even think you would see this on the ACT. You'd sometimes see some harder geometry questions on the ACT, but nothing like up to this level. Yeah, no problem. I think this is a pretty good stopping point, honestly, with that question. So I'll upload the PDFs and everything for this, and let's do Tutor Tuesday again next week. Don't forget, you can check out my free resources, YouTube, TikTok, whatever, on my Explore page, explore.dancetestprep.com. And I hope to see you all next week. See you later.